Okay, let's welcome to Module 4 in Integrated Math 1, and this is Section 4.1, Cafeteria Actions and Reactions, which is a developing understanding task. So let's take a look at the story problem right here. Elvira, the cafeteria manager, has just received a shipment of new trays with the school logo prominently displayed in the middle of the tray. After unloading 4 cartons of trays in the pizza line, she realized that students are arriving for lunch and she will have to wait until lunch is over before unloading the remaining cartons. So Elvira has unloaded 4 cartons of trays and put them all in the pizza line. Okay, what do they want us to do then? Well, let's think about the information here. 4 cartons of trays in the pizza line. So I'm going to start declaring a few variables. So Elvira places 4 cartons, which I'm going to use a C for the number of cartons, of trays, and I'm going to use a T for the number of trays in the pizza line. Now, what do I know? Well, number of trays. Let's call that T, number of trays. And C, number of cartons. So I'm just declaring my variables. And then all they have told me so far is that Elvira unloaded 4 cartons of trays. So Elvira unloaded 4 cartons. C equals 4. Okay. Wow. Okay. A lot of information there. Oh, more information here though. Okay. The new trays are very popular, and in just a couple minutes, 24 students have passed through the pizza line and are showing off the school logo on the trays. 24 students have gone through the pizza line, and they've got the new trays in their hands. All right, so I want to know, so how many trays T are left in the pizza line? Well, the pizza line had T number of trays, and we didn't know what that was. And we have 24 students who had gone through the line. So the number of trays left in the pizza line would be T minus those 24. Okay. Now let's see. At this time, Elvira decides to divide the remaining trays in the pizza line into 3 equal groups, so she can also place some in the salad line and sandwich line, hoping to attract students to the other lines. So everybody's getting pizza because of the new trays. She's got to start selling some salad and some sandwiches. So she's going to take that T minus 24 and divide it by 3. Okay, cool. Now, after doing so, she realizes that each of the 3 serving lines has only 12 of the new trays. So this would be the number of trays in each line, and she found that that would equal 12 in each of them. So each of the 3 serving lines has only 12 of the new trays. So T minus 24 divided by 3 has to equal 12. Okay, so that's not many trays for each line. I wonder how many trays there were in each of the cartons I unloaded. All right, yeah, that'd be something kind of important to know. So if we took this equation and solve for T, wouldn't we have the number of trays in each carton? So trays per carton, here we go then. Okay, can you help the cafeteria manager answer a question using the data in the story about each of the actions she took? Explain how you arrive at your solution. All right, so we're going to take this equation and we're going to solve for T. Solve for the number of trays T that Elvira started with. So that's the number of trays that were in those original 4 cartons. All right, so this is our first real experience in this class. You did this some last year of solving equations. All right, so I've got to solve for this T right here. How am I going to isolate the T? Well, you've got to think about what you undo first. And do you guys see that the t minus 24 is being divided by 3? So if I took both sides of this equation and I undid division by 3, what undoes dividing? Multiplying. Let's just multiply both sides of the equation by 3. And then you rewrite the equation. Remember, when you're solving an equation, all you have to do is the exact same thing to both sides of the equation during every step. So we divided by 3 to get rid of this, or we multiplied by 3 to get rid of this divisor of 3 right here. So those would cancel. And what does that leave me? On the left I have t minus 24. And on the right I have 12 times 3, which is 36. Now I have one more step. T minus 24. How do I undo subtracting 24? Well, I would add 24 to both sides. So add 24 on the left and do the same thing on the right. And now rewrite your equation. So on the left I have t minus 24 plus 24, which is just going to leave me the t. And on the right I have 36 plus 24, which would be 46, 56, 60. So the number of trays that Elvira started with would have been 60. So if the number of trays is 60, then how many trays per carton did Elvira get? Well, there were 4 cartons, right? So just go 60 divided by 4, t divided by c right there, and you'd get 15. So every carton had 15 trays, so there are 15 trays per carton. Wow. That's a big start to a new module right there. But again, remember, this is just an application. What we're going to develop during this module is solving equations. Okay, so you get really, really good at this stuff right here, and you're going to do great. Okay, so let's take a look at the next slide. Elvira is interested in collecting data about how many students use each of the tables during each lunch period. She has recorded some data on post-it notes to analyze later. Here are the notes she has recorded. So Elvira is not only a cafeteria manager, but she is what seems to be a really, really good mathematician. So she has a few notes that she's going to put on post-it notes. 1, 2, 3, 4, 5 notes. And then she's going to use those notes to create an algebraic equation that she can use to answer questions. So let's see. What's her first note say? Some students are sitting at the front table. I got distracted by an incident in the back of the lunchroom and forgot to record how many students. So Elvira would take a little note. Now, what does that mean algebraically? Well, all she has right here is, and look at what her notation, S sub F. She's using that to represent the number of students who were initially seated at the front table. Students at the front table. All right? And she really has no more information on that very first note. So let's go to the second note and see if we can add something. So each of the students at the front table has been joined by a friend, doubling the number of students at the front table. So if the number of the students at the front table were S sub F, to double that, what would Elvira do? Multiply by 2. Okay, let's go to note 3. 4 more students have just taken seats with the students at the front table. So let's take that 2 times S sub F and add 4. Note number 4. The students at the front table separated into 3 equal size groups and then 2 groups left, leaving only 1/3 of the students at the table. So we had 2 times S sub F plus 4, and now we only have 1/3 of that. So I'm just going to show that by dividing by 3. All right, and this is now the number of students that were at the front table. And then finally, as the lunch period ends, there are still 12 students seated at the front table. So this expression, 2 times S sub f plus 4, that quantity divided by 3 would have to equal 12. And that is the equation that Elvira created based upon her 5 post-it notes. Now, let's think. What could she answer with this equation? Could she solve for S sub f, the number of students who were initially at the front table? So how many students were originally seated at the front table? And this is the skill that you need to develop. Let's take this equation and solve for S sub f right there that I put in red. So you got to think, when you're manipulating an equation to solve, you have to do the same thing to both sides of the equation during every step. Otherwise, you change things. So you think to yourself, to isolate this S sub f, what would I have to get rid of first? And what you do is the opposite of like your order of operations when you're solving. So do you see this 3 down here? 2 times S sub f plus 4 is being divided by 3. I could clean this up really quickly by undoing division by 3, by multiplying both sides of the equation by 3. So I'm going to multiply the left-hand side by 3 and the right-hand side by 3. Remember, you have to do the same thing on both sides. Now let's rewrite. And we multiplied to undo dividing by 3. So those factors just cancel now, leaving 2 times S sub f plus 4. And on the right, I have 12 times 3, which is 36. And now we have your typical 2-step equation right here. And again, what are you going to have to get rid of first? Always undo addition or subtraction before you deal with multiplication or division in a 2-step equation like this. Remember, the opposite of your order of operations now. So I'm going to get rid of the plus 4. What undoes adding 4? Let's subtract 4. And what we do on the left, we have to do on the right. Okay, so what's that going to equal? Well, 2 S sub f plus 4 minus 4 would just be 2 S sub f. Plus 4 minus 4 cancels. And on the right, 36 minus 4 is 32. Now, let's undo multiplication by 2. What undoes multiplying by 2? That's right, we're going to divide by 2. And what we do on the left, we have to do on the right. So let's rewrite. And we did that to cancel those factors of 2. Those are gone now. And we are left with S sub f equals 32 divided by 2, which is 16. So initially, there were 16 students at the front table when Elvira took that very first note. Check. Okay, now, number 2. Does it matter which order the notes were recorded in? Determine how many students were originally sitting at the front table based on the sequence of notes that appears above. Then rearrange the middle 3 notes in a different order and determine what the new order implies about the number of students seated at the front table at the beginning. So we already did the first part. Does it matter which order the notes were recorded in? Well, if you go back and if you change the order, that would change our expression here on the left, which would change everything. So yeah, that matters. All right. And it matters because in mathematics, we have an order of operation. Remember that acronym GEMDAS. So what we're going to do is we're going to change the order of the notes and see how that changes our equations. This is going to be a lot of fun. All right, so one more time. Elvira is interested in collecting data about how many students use each of the tables during each lunch period. She has recorded some data on post-it notes to analyze later. Here are the notes she has recorded. So these are the same notes, but we're going to change the order of how she recorded the notes and see what that does to our equation. All right, so Let's start the same way, because the students at the front table, S sub F, will be the students at the front table when lunch began. So we'll start with that. And what are we starting with? S sub F students. Now, let's jump around a little bit. So, yeah, let's go down to this third bullet, and we're now going to call that number 2. 4 more students have just taken seats with the students at the front table. So let's take that S sub F and add 4. Okay, now where do you guys want to go? How about we go to the second bullet, and we'll call that bullet number 3 now. Each of the students at the front table has been joined by a friend, doubling the number of students at the table. So right now we have S sub F plus 4, and if we double that, we have to put it in parentheses and put the multiplication by 2 on the outside. All right, and then bullet 4 will be bullet 4 again. The students at the front table separated into 3 equal-sized groups, and then 2 groups left, leaving only 1/3 of the students at the table. So we're going to take this expression and divide by 3. And we're always going to end with this. Okay? As the lunch period ends, there are still 12 students seated at the front table. So that equals 12. So when we rearrange the notes, we're always going to start with this first bullet as number 1, the students at the front table initially, and we're always going to end with number 5. As the lunch period ends, there are still 12 students seated at the front table. But we'll mix up the other 3 bullets just to see what happens. So now, if this were the case, I'm wondering, what did we have before? S sub F, was it 16? I think so. Let's see if we still get 16. So let's solve. Now, I want to show you something really important. Do you see how the quantity S sub F plus 4 is being multiplied by 2 and divided by 3? Now, we can do that in 2 steps, or if you really want to become a little more efficient, that is taking this quantity S sub F plus 4 and really multiplying by 2/3. And to undo multiplying by a fraction, all you do is multiply by the reciprocal of the fraction. So what is the reciprocal of 2 over 3? 3 over 2. And what we do on the left, we have to do on the right. Now, why did we do that? Watch. So the 3's would cancel here, all right, and the 2's would cancel here, because I have a factor of 3 in my numerator, a factor of 3 in the denominator. Those cancel. A factor of 2 in the numerator and a factor of 2 in the denominator. Those would cancel, leaving S sub F plus 4. And then, what is 12 times 3 over 2? Well, again, just to show things, how many times does 2 go into 12? 2 goes into 12 6 times. So that's going to leave me 6 times 3, 18. Isn't that cool? And now we only have one more step. We've got to undo adding 4. What undoes adding 4? That's right, subtract 4. And what you do on the left, you have to do on the right. So that equals, well, S sub F plus 4 minus 4 is S sub F. And S sub F has to equal 18 minus 4, which is 14. So by changing the order of the post-it notes, we have changed the initial number of students at the front table. I believe on the previous slide we had 16, and now we have 14. Cool. All right. Now, number 3. Here are 3 different equations that can be written based on a particular sequence of notes. Oh, very cool. So they're going to give us the equation, all right, and we're going to put it together, all right? So examine each equation and then list the order of the 5 notes that is represented by each equation. Find the solution for each equation. Now, they're now using x instead of S sub F. So just remember, x is the initial number of students at the front table. And do you see this 2 times the quantity x plus 4 divided by 3 equals 12? that looks really familiar to me. And that's why I have these notes in the same order that we had on the previous slide. So if I go back, let's see, how can I go back here? All right, let's go backspace. Look at our equation. 2 times the quantity S sub F plus 4 divided by 3 equals 12. And we solved that, and we got S sub F equals 14. So on this problem, if we solve this, we'll get 14 again. So we're not going to do that again. We just did this one. So let's move on to a new problem where they're going to give us an equation, and we're going to write the order of the notes and then solve the equation. Okay, number 3. Okay, let's just make sure. I think we may have already seen these instructions, but let's take a look and make sure. Here are 3 different equations that could be written based on a particular sequence of notes. Examine each equation and then list the order of the 5 notes that is represented by each equation. Find the solution for each equation. Well, first, you're going to start with your variable, and they're using an x. We use S sub F, Elvira did. So this first bullet will always be number 1, okay? And that's some students are sitting at the front table, and we're calling that x now. And then we're always going to end with this equals 12. So 5 will be the last bullet. As the lunch period ends, there are still 12 students seated at the front table. And then we've got to look at this expression over here on the left to determine what this expression means for the order of these notes. So what did we do to the x first? We divided by 3. So which bullet is division by 3? I think it's this one here. The students at the front table separated into 3 equal sized groups, and then 2 groups left, leaving only 1/3 of the students at the table. So this becomes our second bullet now. And then what did we do to the x over 3? We added 4. Order of operations here. So what bullet is that? 4 more students have just taken seats with the students at the front table. So that's now my third bullet, which means the fourth bullet would have to be this one, but let's make sure. Each of the students at the front table has been joined by a friend, doubling the number of students at the table. So we're multiplying all that by 2. That's 4. All right. Now let's solve this equation for x to see how many students began at the front table. So here first, well, if we're going to isolate this x, we had better undo. See how we're multiplying the quantity that has the x in it by 2? How about if we divide both sides by 2 first? So I'm going to divide the left by 2, and I'm going to divide the right by 2, because what I do to one side, I always have to do to the other. Now we did that because now these factors of 2 will cancel, leaving us x over 3 plus 4 equals 12 divided by 2, which is 6. Now, you have to get rid of the addition. So what undoes adding 4? Subtracting 4. And you're going to need to do that to both sides of the equation and then rewrite. So x over 3 plus 4 minus 4 is just x over 3. And 6 minus 4 is 2. And now undo division by 3. What undoes division? Multiply by 3. And do it to both sides. And you do that, so now your factors of 3 will cancel, leaving x equals 2 times 3, 6. So in this scenario, with the bullets in this order, 1, 2, 3, 4, and 5, there were 6 students at the front table when lunch started. Okay, one more equation. 2 times x plus 4 divided by 3 equals 12. That looks familiar. Okay, but let's put things in order, and remember, the first bullet is 1 and the fifth bullet has to be 5. 1 and 5. Now, let's think about what are the order of the other 3 bullets. What did we do to the x first order of operations? We multiplied by 2. So, each of the students at the front table has been joined by a friend, doubling the number of students at the table. That becomes the second bullet now, or the second note. And then what are we going to do to the 2x? Well, before we divide by 3, we're going to have to add that 4 right there. So, 4 more students have just taken seats with the students at the front table. So that would be my third bullet now. And then, what are we doing to the 2x plus 4? We're dividing by 3. The students at the front table separated into 3 equal-sized groups and then 2 groups left, leaving only 1/3 of the students at the table. There it is. And there's the division by 3. And look at 1, 2, 3, 4, and 5. Isn't that the first problem that we did, except instead of using x, Elvira used S sub f to represent the number of students at the front table? That's the first problem. And if I remember right, our S sub f was 16. So just to practice and make sure we really got solving equations down, let's take this equation and solve for x. And I hope we get an x equals 16. Otherwise, we have a little work to do. So, if I look at 2x plus 4, all of that quantity over 3, if I'm going to isolate that x, the first thing I have to do is get rid of that division by 3. So what undoes dividing by 3? Multiply by 3. And do that to both sides. So, the factors of 3 will cancel, leaving us 2x plus 4. We're getting closer to solving for that x. And what does 2x plus 4 have to equal? 36. Now, we've got to get rid of this addition. What undoes adding 4? Subtracting 4. So when we do that, 2x plus 4 minus 4 is just 2x. And on the right, 36 minus 4 is 32. And then we have to undo multiplication by 2. Let's divide both sides by 2. There's the left. There's the right. So what do we have? Well, the 2's cancel now, leaving us x equals 32 divided by 2. And that's 16, and that is what we were hoping to get. I think we have solving equations down. All right. Hope you guys had as much fun as I had. Let's make sure we get the 4.1 Ready, Set, Go done, and I'll see you in a couple days.